Hello everyone, happy International Teaching Week. Mm, I am Ali Abbasi, Assistant Professor in Sport Biomechanics at Khwarazm University. In this presentation, I want to speak about the effect of menstrual cycles on lower extremity coordination variability during roundhouse kick in female taekwondo players. Okay, so Taekwondo is a martial art. It's a famous martial art that in the Taekwondo, 90% of scores get by leg kicks, and the last 10% is get by hand kicks. And the roundhouse kick constitutes of 50% of all kicks for combatant in Taekwondo. What is the roundhouse kick? You can see it in the pictures. You can see the roundhouse kick cycle. At the first, putting leg down. And at the first, athlete try to move his or her leg in the kicking starts. At the kick starts in the sagittal plane. Generally, the kick start, roundhouse kick start from the sagittal plane and finish in the frontal plane. The leg movement start from the sagittal plane and finish in the frontal plane. The first step is swing phase. In this cycle, hip start from 10 degree of flexion and 1 to 2 degree of abduction, and reach from the start to the swing phase to the finish swing phase. And after that, it reaches to 60 degree of flexion and 60 degree of abduction at the impact target. The next step is impact target. In this cycle, ankle start from 5 degree of plantar flexion. You can see here. And after that, ankle goes to 50 degree of plantar flexion at the impact target in this time. And after impact target, it's the kicking return cycle. In this cycle, knees start from 10 degree of flexion and reach to 90 degree of flexion at the finish of swing, and continue from 90 of flexion at the swing to full extension at the impact target. And after this cycle is putting leg down and finishing the roundhouse kicking cycle. Research showed that in Taekwondo, injuries in lower extremity is about 45% for males and 53% in females, lower extremity injuries. And in categorizing the injuries places, researchers show that the most place for lower extremity injuries is knee and ankle, and after that foot, toe, and hip. Why the female more probable of lower extremity injuries, the researchers says that one of the biggest differences between male and female is menstrual cycles, and it may cause the more probability of female injuries, more percent of female injuries, lower extremity injuries than males. Menstrual cycle is a physiological phenomenon which repeats every month, and cover totally 30 to 35 years of a woman's life. Researchers categorize the one menstrual cycle to 3 cycles. The first cycle is follicular phase, to this 3 phases. The first phase is follicular phase. In the first cycles or follicular phase, we can know that level of estrogen and progesterone is very low, and in the second phase of menstrual cycles, the estroidal level reaches its peak and progesterone start to increase. And in the last phases of menstrual cycle, luteal phase, the progesterone level reaches its peak and estrogen decrease. Then we can see that these differences in fluctuation in hormonal progesterone and estrogen can affect the physiology of woman's body, or we call in the physiology of a woman body, especially in female athletes. Okay, as we stated, the lower extremity injury rate in Taekwondo is more in female than in male. Maybe anatomical, hormonal, biomechanical differences between male and female can explain the different ratio of these injuries, and researchers try to examine these differences, and one of the biggest differences in male and female, as I told, is menstrual cycles, and because of this, we wanted to examine the menstrual cycle effects on the biomechanical roundhouse kick. The question is there any differences in lower extremity joint coordination variability in these 3 phases of menstrual cycle during roundhouse kicks? In the review of the research in Taekwondo and in the menstrual cycle and biomechanics, we found research about this, and for example, the effective phase of menstrual cycle on frontal plane, knee kinematic during landing, researched by Jennifer at 2005, and after that, a relationship between knee joint laxity and knee joint mechanics during different menstrual cycles, researched by Park et al. And as you can see here, the most researchers on the menstrual cycle focused on the physiology of the physiological aspect of the human movement, female movement, and in the biomechanical consideration, the more focus was on the frontal plane knee kinematics. during landing or during squatting. And in this review of the researches, we could find some researches about the interjoint coordination during taekwondo kicks, but it doesn't consider the menstrual cycles. And for instance, for example, segment coordination, coupling and coordination variability analysis during roundhouse kick were done during taekwondo, but menstrual cycle weren't examined during didn't examine during this researchers. When we wanted to examine the effect of coordination, effect of different menstrual cycles on coordination and coordination variability of lower extremity joint in female during roundhouse kick. Reviewing the research showed that taekwondo studies examined the lower extremity injury showed that lower extremity injuries is in female is more than male, and during biomechanical analysis, the effect of menstrual cycle were examined on on a single joint mechanics. For example, more of them examined the knee mechanics during different tasks like squat and landing and single leg landing. However, coordination as a nonlinear dynamic analysis system analysis can give a better insight regarding the joint mechanics in a kinematic chain. And on the other hand, coordination variability give an insight regarding flexibility of system in response to condition to condition. And we know that decrease in coordination variability can increase the probability of injuries in athletes. And we saw the discrepancy in the result of researchers on the effect of menstrual cycles on the joint biomechanics. Some of researchers showed that there were significant differences in, for example, knee valgus angles during different menstrual cycle, but some of researchers didn't show any significant differences in different menstrual cycles. We did this research in the Tehran, Iran, and 8 skilled taekwondo players from national team Iranian national team member, taekwondo member, participated in this research. They were about 28 to 30. So they was in 18 to 20. Their menstrual cycles. They had normal menstrual cycle, and demographic. Their demographic data is here. At the first, we recorded the subject anthropometric information, and we used 16 reflex markers on their bodies based on plug-and-gate model, and fixed all markers by tape. First, we did we captured one static test in a standing position with 8 vehicle motion capture at the frequency of 240 frame per second. After that, each participant distance target for kicking were selected according to their lower limb height, and during every presence of a participant in our laboratory, each participant performed 9 roundhouse kick and we captured the kinematic data from this 9 roundhouse kicks in each menstrual cycles. In data analysis, we use the different softwares, for example, Nexus for data capturing, for data labeling, gap filling, and data filtering. We used Excel for chart preparation and MATLAB custom written code for data normalization, CRP calculation, and for statistical analysis. And also we use the SPSS software for data analysis. We did the labeling, gap filling, and filtering in the Nexus, and we did data were low pass filtered by Butterworth, low pass filtered by at cutoff frequency of 6 Hz. And after that, we used the methods the methods of Hamil's for calculating the continuous relative phase or CRP and CRP variability during roundhouse kick. First, joint angle data were normalized to 100 data points, and the CRP was calculated based on this formula. First, the angles were normalized by this formula, and angular velocity were normalized based on maximum angular velocity. At the second step, we construct the phase plane for each joint and calculated the phase angle by this formula and tangent inverse of omega on theta. After that, we calculated the CRP angle of the coupling to joint by subtracting the proximal from distal joint phase angle. This period or this formula gave us 100 data point of the CRP values, and each values has different meaning. For example, if the CRP is between 0 to 30 degree, it means that we have in phase with proximal joint dominancy. In phase means that two joints move in the same direction. For example, two joints move in the same clockwise or counterclockwise direction. If CRP is between 30 and 150 degree, it means that the movement of two joints is out of phase and with proximal dominancy. And we can see the other meanings of the CRP. This is a schematic explanation of calculation of CRP. This is for hip joint and it's for knee joint. This is the theta and omega of the means joint angle and angular velocity of hip angle. After that is face plane. We we construct the face plane for each joint, and after that we calculate the phi angle or phase angle for each joint, and after that subtracting the phase angle of the proximal to distal to construct the to calculate the CRP. In the result, you can see that in the hip flexion extension, knee flexion extension, this is the pattern of CRP, and for each quadrant, we calculated the frequency of CRP, and we compared the CRP frequency between different menstrual cycles by SPSS software. As you can see, also we calculated the joints range of motion and compared the joint range of motions between different menstrual cycles. As you can see, the joint range of motion, there weren't significant differences in joint range of motion between different menstrual cycles. For hip flexion extension and knee flexion extension. Also, we couldn't find any significant differences in CRP in hip flexion extension and knee flexion extension during different menstrual cycles. However, we can find from the CRP plot that in the first 50% of the kicking, we had during swing to impact, during phase of swing to impact, we can see that the knee moved faster than the hip in this period, and after that during kicking return, hip moved faster than the knee. And we found that in follicular and ovulation phase, the movement of these two joints are out of phase with more knee dominancy. And in luteal phase, we found that the movement of these two joints is in phase with hip dominancy. But none of them were significant between different phases of menstrual cycles. And this plot is for hip abduction, adduction, and knee flexion extension CRP coordination or coupling movement. And there weren't significant differences in joint range of motion, and also for joint coupling angles between different menstrual cycles. However, follicular and ovulation phase and luteal phase, during these phases, the most movement of hip abduction, adduction, and knee flexion extension were out of phase with hip dominancy. However, moreover, we saw that less variability, but not significant in target impact of the roundhouse kick. Also, for hip internal external rotation and knee flexion extension, we couldn't find any significant differences between joint range of motion and coupling angles. And during swing phase, again, we saw that knee moved faster, and during kicking return, hip moved faster. And we found that in all of the menstrual cycles, we found the more out of phase movement with knee dominancy, and again we found less variability but not significant during impact target. For the hip abduction adduction and knee abduction adduction coupling, we couldn't find any significant differences between joint range of motion and also coupling coupling angles. And also we found that during swing phase, knee moved faster, and we found that the more coupling pattern was in the three menstrual cycle was out of phase with knee dominancy. And again, we found less variability, but not significant in target impact. Moreover, we found that knee adduction were more but not significant in follicular phase of the menstrual cycles. During hip and knee flexion, also we found that the knee flexion extension range of motion was more in during ovulation phases. Okay, for hip flexion extension, ankle plantar dorsiflexion, we couldn't find any significant differences in joint range of motions and also in the coordination coupling movement of these two joints. During first 50% of kicking phase, ankle moved faster, but during the second 50% of kicking phase, hip moved faster, and the most coupling patterns were out of phase with ankle dominancy in this in all of the menstrual cycles. For hip abduction, adduction, and ankle plantar dorsiflexion, again we couldn't find any significant differences in joints range of motion and also for the coordination patterns. But the more coordination pattern for these two joints were out of phase with ankle dominancy during three phases of menstrual cycles, and again we found less variability but not significant in the target impact. For knee flexion extension, ankle plantar dorsiflexion, again we found no significant differences between joint range of motion and coupling angles. But the more this coupling angle was coupling pattern were out of phase with ankle dominancy and less variability. We found with less variability but not significant in target impact. We compared the result of coordination variability or CRPV by SPM methods. SPM methods compare 100 data points at the same times between different menstrual cycles. However, after running the SPM on the coordination variability, we couldn't find any significant differences in CRPV between any cycles of menstrual cycles. However, we found from this coordination variability pattern that we had less coordination variability during impact phase of the roundhouse kick cycles. In conclusion, we found that knee had more range of motion in frontal plane during follicular phase of the menstrual cycles, and knee range of motion were more in sagittal plane during ovulation cycle of the menstrual cycles. As and it can be concluded that knees may be at higher risk for injuries during follicular and ovulation phases of menstrual cycles as a result of greater range of motion in these two cycles. Moreover, the more changes in coordination pattern were presented during impact target, but it weren't significant between different menstrual cycles. However, the less mm, we couldn't find any significant differences between these menstrual cycles. It may be as a result of being professional taekwondo players, women, because the female were professional taekwondo players, and may they adapt to their hard training, and we couldn't find any significant differences between the coordination patterns of lower extremity joint. Generally, we had the less coordination variability during impact target of the roundhouse kick cycles. And as we know, the less coordination variability may increase the risk for injuries in joints and segments. And we can conclude that we couldn't see significant differences between this coordination variability, but however it may indicate that the athletes are more susceptible to injuries during lower extremity injuries during this phase of I mean the impact target of the roundhouse kick. Practical suggestion from this research can be that since the most changes in the knee range of motion in sagittal and frontal plane were seen during the follicular and ovulation phase, it is suggested that female athletic taekwondo players care more about their exercises intensities during these menstrual cycles. And since we saw the less coordination variability during impact target, the risk of injuries in lower extremity joint are higher during these cycles of taekwondo roundhouse kick, and the coach and athlete should be careful of this cycle, impact target, during their exercises and also during their combats. Future suggestion can we say regarding the adaptation to long term of exercise in these athletes. It suggests that future studies investigate the effect of menstrual cycle in novice and elites, and compare between novice and elite athletic taekwondo players. And it's suggested to examine the coupling variability in pelvis and trunk also, because trunk and pelvis motion is very important during roundhouse kick. And in this study and former studies, the roundhouse kick technique were examined. However, it's possible that other kicking techniques show different results in coordination variability. So it's recommended to consider other techniques during taekwondo athletic task. And thank you for your attention. And again, happy International Teaching Week from Iran.